We are the Gujarat Technological University. Since its inception over a decade ago, GTU has been empowering young and curating minds to realize their true potential. Over 4 lakh inspired students are enrolled with one of the premier academic universities in India. With more than 450 affiliated colleges in its fold operating across 5 zones of the state, GTU, the International Innovative University, your place to move forward.
I have said here the syllabus of GTU is Electronics Communication, 4th semester. Now say this signal system subject. I have just want to verify syllabus with you. Say this introduction to signal system, classification of signal system, signal operation, basic continuous time signal. This is the topic that already completed in my lecture. If you can refer my first to 6 or 7 lecture. And also we have completed Z transform, conversion of Z transform and properties of Z transform that we have already completed in the class. My class, myself is Jaymin Sanghani from VYAVASAYI Engineering College. Now onwards we have discussed the chapter number 2, behavior of sampling, behavior of continuous time and discrete time LTI system. We have discussed on this chapter, chapter number 2. So please concentrate on the chapter number 2. Whatever I have discussed here, it is I have set the screen to you. So here, say this. I have discussed the unit number 2 from this lecture. Whatever part related to sampling and that I will discuss on later on. And whatever I have discussed related to signal and system operation that already completed in previous lecture. So here we can discuss. So in this lecture we have discussed on the topic convolution integral. Convolution integral for CT-LTI system. CT-LTI system means what? Continuous time, linear time invariant system. Now, for CT-LTI system, derive the equation of convolution integral. Convolution means what? It is the simple process of addition and multiplication of different continuous time signals. Now see, here T, here we can say X of T. See, this is the random signal. See, this is the random signal. Now, see, here which is known as 1. So here it is considered as a delta of T minus 1. Delta of T minus 1 means what? Unit impulse signal. Unit impulse signal. Now this can be multiplied with here. This can be multiplied with here. So here we can get here time axis. So here we can get the value which is known as x of 1 into delta of t minus 1. Delta of t minus 1. Similar for different value, we can multiply. So here x of t, entire x of t can be represented in terms of delta. Delta of t minus 1, if you can multiply with this, तो only get with this answer. We can get only this answer. अभी multiplication करो, if you can simply multiply with, then we can get only one particular value. So similar type of way, I have shared with PDF to you. See this. This is the random signal. X of delta of t, here delta of t minus 1, delta of t minus 2. So here x of 1 into delta of t minus 1 set for a particular point. Say this is the particular point. Say for particular point, delta of t, if you can multiply with this, here if you can multiply with this, see this. Here if you can multiply with this, here if you can multiply with this, here if you can multiply with this, so here we can get the output at the sufficient level, x of t equal to x of 0 into delta of 0 plus x of 0.5 into delta of t minus 0.5, x of 1 delta of t minus 1, x of 1.5 delta of t minus 1.5, x of 2 delta of t minus 2, x of 3 delta of t minus 3, plus up to plus x of n delta of t minus n. Now see, 0, 1, 2, 3, 4, 5, it is known as main variable. Main variable means what? See this, here his value is changed 1, 2, 3, 4, 5. So here we can say x of t equal to minus infinite to infinite integration x of tau delta of t minus tau d tau. See this, x of t that can be represented in terms of delta. See here, x of t that can be represented of delta, represent in terms of x of delta. So minus infinite to infinite integration x of tau delta of t minus tau d tau, which is equal to x of t. Now this x of t that can be passed from the system. See this. Now x of t that can be passed from the system means what? Simply say control system or any particular type of system. If you can pass x of t from system, then y of t equal to h of t. Why? Because here x of t that can be represented in terms of delta of t. X of t that can be represented in terms of delta of t. So here input x of t equal to delta of t. Here input x of t represent in terms of delta of t and unit impulse, then output equal to step response. So here minus infinite to infinite x of tau delta of t minus tau. If delta of t applied to the input means unit impulse, then output equal to y of t equal to h of t. Means what? I have write in the whiteboard, if unit impulse signal that can be applied to the system, then y of t equal to h of t. If unit impulse signal that can be applied to the system, then y of t equal to h of t. Y of t equal to h of t. And if delay input of impulse signal means what? Delta of t minus tau impulse signal that can be applied to the system, then y of t minus t equal to h of t minus t. It is considered as a output. It is talking about the output signal. Now see this particular PDF, delta of t minus tau. So output it is known as h of t minus tau. So y of t equal to minus infinite to infinite integration infinite integration x of tau h of t minus tau d tau. So this is the final equation that we have represent here. Now see, this is the equation of convolution integral. Now properties of convolution that I will be discuss on the next lecture. Now see here, using convolution integral determined to find response of the system, LTI system, with an impulse response h of t equal to e raised to minus beta t u of t and x of t equal to e raised to minus alpha t u of t, where alpha equal to beta and alpha not equal to beta. So determine the convolution integral, or we can say determine the output of the system. So apply the definition of convolution. Y of t equal to x of minus infinite to infinite integration x of tau into h of t minus tau, which is equal to, we can represent here, x of t convolution with h of t is equal to y of t. Now x of tau equal to e raised to minus alpha tau u of tau, h of t minus tau equal to e raised to minus beta t minus tau u of t minus tau. See this, t can be converted into tau. Now tau can be considered as a main variable. See this entire equation. Tau can be considered as a main variable. Tau can be considered as a main variable because why? Because tau equal to 1, 2, 3. So it can be variable. It is not considered as a constant. So here 1, 2, 3 can be considered as a variable. So here minus infinite to infinite integration x of tau h of t minus tau d tau. So here e raised to minus alpha tau u of tau e raised to minus beta t e raised to beta tau u of t minus tau d tau. So u of tau into u of t minus tau d tau, which is equal to 1. See this here, which is equal to 1. And here e raised to minus beta t common. So here e raised to minus e raised to beta e raised to tau common, bracket ma beta minus alpha. In the bracket of beta minus alpha, see this here, or we can say minus alpha minus beta. Now u of tau into u of t minus tau. Now see, put here, consider tau equal to capital T equal to 0. Put inside the value of 0. So t equal to 0 and t minus capital T, which is equal to always 0. So t equal to capital T. So that's why 0 to t e raised to minus bracket ma alpha plus beta tau d tau. Now u of tau into u of t minus tau, so it is considered as a 1. Why u of tau into u of t minus tau it is considered as a 1? Because see this, see here it is known as tau, here it is known as u of tau. See this here, tau is main variable, here amplitude of u of tau, which is equal to 1. Now u of t minus tau, so here we can say u of minus tau u of minus tau, which is equal to 1, and u of minus tau plus t. So here we can say u of minus tau plus t means what? U of t minus tau. Now if you can multiply with this, so here we can get final limit with 0 to t. Here amplitude 0, here t, and here amplitude is 1. So u of tau into u of t minus tau, which is equal to 1. I have mentioned here in the diagram. With the value 0 to t e raised to minus alpha plus beta tau d tau. So if you can take integration e raised to minus alpha plus beta tau into t minus alpha plus beta 0 to t. So if you can manipulate the limit, so we can get the answer alpha plus beta bracket ma 1 minus alpha e raised to minus alpha plus beta plus t. Now if you can put alpha equal to beta, so 2 beta in the bracket of 1 minus e raised to minus 2 beta t answer. So this is the answer for alpha equal to beta. Now second example, using convolution integral, determine to find the output response y of t of LTI system with impulse response h of t equal to e raised to beta t u of t and x of t is equal to e raised to minus alpha t u of t, where alpha equal to beta and alpha not equal to beta. Now see, converted first step as usual, x of t into x of tau. So x of tau equal to e raised to minus alpha tau u of tau, and h of t minus tau equal to e raised to beta t minus tau u of t minus tau. So here we can take e raised to beta tau. Here we can consider x of t equal to h of t. Here we can consider x of t equal to h of t. There is no change in the x of t and h of t. Why? Because use the convolution property. What is the convolution property? Says that x of t convolution with h of t is equal to h of t convolution with x of t. So here we can say h of t equal to x of t. So e raised to beta tau u of tau into e raised to minus alpha t minus tau u of t minus tau d tau. Now e raised to minus alpha t e raised to alpha tau into e raised to minus beta tau u of tau into u of t minus tau. So it is considered as a 1. Ideally this value which is equal to 1. U of tau magnitude 1, u of t minus tau also magnitude 1. So here we can say the limit between 0 to t. See this here. 0 to t. 0 to t e raised to alpha minus beta tau into d tau. So e raised to alpha minus tau divided by alpha minus beta, range between 0 to t. So here e raised to minus alpha t upon alpha minus beta, e raised to alpha minus beta into t minus e raised to 1. It is the final answer. Or alpha not equal to beta. But here alpha equal to beta, then say that alpha equal to beta, so e raised to 0. Alpha equal to beta, so e raised to minus beta t d tau. So t e raised to minus beta t, it is the final answer. For e raised alpha equal to beta value. This is alpha equal to beta. Clear? So it is the final answer related to this particular example. For further example, we will discuss in the next lecture. In next lecture also we have discussed the properties related to convolution integral. Basically 3 properties. I have mentioned the name here: commutative, associative, and distributive. 3 type of properties that can be present. Commutative property, commutative property x of t convolution with h of t equal to h of t convolution with x of t. So it is known as commutative property. Second, which is known as distributive property, x of t convolution with bracket ma h1 of t plus h2 of t is equal to x of t convolution with h1 of t plus x of t convolution with h2 of t. So it is known as distributive property. Commutative property means what? Simply say here, we can write 3 multiplied by 5 equal to 5 multiplied by 3. Simply say it is known as commutative. Distributive system means what? Consider this is the system H1. Consider this is the system H2. These two systems are connected in cascaded. Sorry, two systems are connected in parallel. Then overall system or overall response of the system. See this. This is the overall system, and if you can add with each other, if you can add with each other, then it is known as distributive property. So I will explain the proof of this property in the next lecture. So I have basic introduced the properties of convolution. Based on that, we have proved this property on next lecture, and we can do the further example related to convolution. Basically, in 4 lecture, convolution, CT-LTI convolution can be completed. DT-LTI convolution can be still pending. It will be discussed on the next lecture. Next lecture. Thank you very much.